right, welcome back. We are on the second page and we are going to be using the graphing calculator here, and it's pretty important that you do have your graphing calculator when we take this test. So let's just review the three formulas. I realize they are on our yellow cheat sheet, but I'm going to write them down so that we realize which one is which. So the first formula we learned was this one. And again, just a reminder of what the different things are. B is always the beginning amount, that's how much you start with. R is your rate, that's that percent that you're going to see that you need to turn into a decimal. Your exponent will be time, whatever they give you. And then Y is going to be the new amount. And we're going to use this just if they talk about something increasing or decreasing. And use the plus if it's increasing, use the minus if it's decreasing. The next formula we use is, as I said in the graphing video, is just think of this B as flipping, and it's called the principal. And again, there's always one, and then you either add or subtract. Usually in our case it would be adding, and then you're going to have a fraction, and in that fraction, now your rate is the numerator, and N is how often they decide to charge you or give you however much money. So that's called the interest. Are they charging you interest? Are you earning interest? So you'll see the word compound. And they might use, for instance, daily or weekly or something like that. And that's your N. And when you work with the graphing calculator, because of the different models that are out there, you'll want to put that fraction in parentheses so your calculator knows it's a parentheses. And so we're still going to close the parentheses from the side like this, and this time our time will also have that N being compounded in there as well. And what it's doing is it's just taking this formula, which is more based on a yearly idea, and if they are charging you or you are earning interest weekly, it's turning that formula to be a weekly formula. So it's turning your rate, which is supposed to be typically a year rate, into a weekly rate. And then it's taking your time, which is also in years, and it's turning it into a weekly timeline instead. Then there's this formula. So again, you're going to see P. And then E is a value. It is not, you cannot use 2.7 either. You need to be using the E button on your calculator. I will remind you where that is. And this time R is in the exponent and T is here. And you're going to use this formula when they say compound continuously. Now, these all have the built-in increase versus decrease, increase plus, decrease subtract. Same here. In this formula is designed to be for increasing only. So if you do see that they are describing a decrease, the only way to get that decrease is to make your R become a negative value with T. All right? All right, let's get started. So we're going to call this Formula 1, Formula 2, and Formula 3. So it's just a quick reference guide. All right, in 2000, the world population was about 6.09 billion. The world population is increasing by about this percent each year. So first we're just going to write the function P of T that models the population at any time after 2000. So that's where we're going to start. So if you'd rather use Y, that's fine, but I guess I'll stick with what they're asking. So P of T, so the population depending on the time. And I did not see any word of compound in here. So that means I'm using this first formula. So I'm going to put a 1 over here as a reminder as to which formula we're going to use. And we're going to take our beginning amount and we're just going to leave it in the format of 6.09. We're not going to change that into billion. Then I'm going to do the parentheses, 1, and since they say it's increasing, I do want to use the plus, and I'll have to turn this into the decimal. And I think the easiest way is just move your decimal 2 times to the left, which means we would have to fill a 0 in. So I'm going to put that in there. And then T for any time after 2000. So that's just a general formula I can use no matter what I'm given. So now what would the current population be? Well, if the current year is 2021, that means our time, we've had 21 years past. And when you do take this assessment, I really encourage you to write down whatever you're going to type into your calculator in case you mess up some button pushing. So what I've done here is I've just added these two up, and now in for t, I'm going to put 21. And then I just go to my graphing calculator, and I type that in exactly as I see it. And then just to ensure that I don't have any mistakes, I just double check that I got everything typed in correctly, hit enter, and now when I give my answer, I'm going to give it in the same format that they did. So after 6, they went 2 decimal places, so I'm just going to copy that format and say 8.32. You could round it to 8.33. It's really up to you. So I'll round this time. People. All right. The other thing I'd really like for you to do is to use the correct units of measurement in your answer. All right, our next formula is you buy a new F-150 for $48,000 at an annual interest rate of 55.4%. So that means they're going to charge you, the interest is supposed to be based on a year, but no one pays a car payment once a year. You tend to pay it monthly. So the fact that this says compound monthly, the first thing I want to take away from that is my end value is going to be 12, and that I should be using the second formula. So again, first thing we're going to do is just write the function that models it after t years. So if you aren't comfortable with y, you can change it to vt. So this is the value of the car depending on time. And looking at my model, p is my beginning amount. So I bought the truck for $48,000. And I have to realize that a car, even though they aren't saying this, does lose value. So the value of the car will be going down. So I'll use minus. I'm going to take my rate, moving that decimal 2 times to the left, and I'll put it over my n, which is 12. And then for the sake of the calculator, I want to wrap this in parentheses. And then here's the original parentheses, and then I'll put my time in there for any year, so t, and then put the n there as well. And you can put the 12 first and then the t, that doesn't matter. Now some of you with your calculators might need to wrap this one in parentheses as well, and I did not do that at the top. So what's the value after 2 years? So again, please write down whatever it is you are about to type in to your calculator. And so now in for t, I'll put 2. And just for some of those older models of the calculator, I'm going to wrap that in parentheses. So now we want to look, typing this in, and I'm just going to type it in exactly as I see it. So make sure you get all the zeros, that you don't throw any extra zeros in there. So notice I wrapped my fraction in parentheses, and then I have the parentheses for the 1 plus or minus part. And then for exponents, now because mine raises, I don't need to put these exponents. But if you type it in and you see that mountain caret key, you have to wrap your whole exponent in parentheses. So 2 times 12, you could already do 2 times 12 and just type in 24 if you want. And so now I'm going to look. This is money. That's the other thing you do need to think about. What should I write down for an answer? And so money always goes 2 numbers behind the decimal. And if I think about this, if a car is decreasing in value, look at your answer. This should be less than this, and it is. So my car is now worth $43,075.62. So now how long will it take for the car to be worth the value? I'm going to use this model again, and when the car is worth half its value, that means it's worth $24,000. So that's that new amount. That's where y would go. So I'm going to use my new model, where y is, which is v of t. I'm going to put in 24,000. Here I'm just writing everything I'm about to type into the calculator. And this time I don't know t. That's what I have to figure out, how long. And then there goes the n amount for monthly. And this is one where you do not know how to solve for this exponent. So we have to use y1 and y2, and I will write down the dimension windows as we go through them, and when you take your test, the dimension windows, you'll have those provided. So I'm going to go to my y equals, and I'll put 24,000 in for one of the y's, 48,000, the other equation, and again, please just make sure you're typing this in correctly. Now, I can't choose t, I have to use the x part. And now I'm going to go to the window. So you could probably think about this window. Y is all about the price of the car, the original price of the car, and then the newer price of the car. So when I think about Y, you know, the car's never going to be worth more than 48,000, and I only need to get to 24,000. So you kind of think of that as maybe a Y max and a Y min. And then as far as time goes, you know, the least amount of time, that's our X value variable, is going to be 0. And then if you think about how long a truck is going to last, maybe 15, 20 years, especially when we're just going to half its value, it wouldn't even be that much. So for X, for min and max, I'm going to put 0 for my min, because I would never have fewer than 0 years. And let's just say I'll put 20 years in. That sounds about right for a timeline of a truck. And then Y min, again, Y is all about the price of the car. So I only have to get to 24,000. So maybe we just go lower. I think you should always go lower. So I'll put in 20,000. And then the most the car is ever going to be worth is 48,000. So maybe I'll put like 55,000. You definitely want some buffers on both ends so you can see the whole picture. And then I'll hit graph, and hopefully this works. So there is that 24,000 line. Here comes the 48,000 side. This is my Y2. And as long as you can see them meet, that's all you need. Sorry, it goes slow. And then from there, do not hit the trace button. I need exact. So if it's not exact, you're not going to get the points. You need to hit second trace, choose intersect, and then just move your cursor, the flashy thing, close to where it is, and hit enter 3 times. And so now I can see that it's 12.8, etc. So for time, we're going to go 3 decimal places. So this is me writing the 3 decimals. So 12 years, and then this is the months. If you really want to know how many months that is, you can take 0.807 times 12, because there's 12 months in a year. So in 12 years, and about 9 months, so we'll just say 9.7 months, so not quite 10 months, but close to it, is when the car is going to be worth half its value. But I'm also fine if you just write this. All right, the next one. Scientists have cloned the black-footed ferret, this is true, from genes of an animal that died over 30 years ago, and a first for U.S. endangered species. The cloned ferret, named Elizabeth Ann, was born on December 10th, and the successful cloning was announced on Thursday. The young animal is a genetic copy of a ferret named Willa, who died in 1988 and whose remains were frozen in the early days of DNA technology. So this is all true. This was just announced like 2 weeks ago. So in 1950, the population of the black-footed ferret was approximately 4,500. The current population is roughly 124. So at what rate is the population decreasing by? So we're going to write our equation and figure out where the things go. So the one thing I noticed is there was no mention of the word compound, so we will be using option 1. All right? And let's go ahead and fill this in there. So our new amount is the 124. Our original amount is the 4,500. And then in parentheses, I do 1 minus, and this time I don't know what R is. That's what I'm going to figure out. And if we think about that, this is the population in 1950, and currently it's 124, then how many years have passed since 1950? You can just subtract your current year of 2021 with 1950, and you're going to see that your time is 71. So there's 2 ways you can do this. One is you could use the graphing calculator. We'll look at that in just a moment, y1 and y2. But what you do know is that to solve for is you can solve for r when it's not an exponent. You just have to start getting r alone. And that's where we just work backwards in our order of operations. So that's what I'm going to show you first, and then we'll go from there. So trying to get r alone, there is addition, subtraction, but that's in the parentheses, so I'll have to save that for last. So instead what I'll do is move the multiplication division, which this 4,500 is multiplying to all of this, so I'm going to take 124 and divide it by 4,500. And I want you to notice there's a lot of numbers in the decimal. I'm going to write a few of them down. But I'm still going to let my calculator use all of these numbers. So now the next thing to get rid of is the exponent. And to get rid of a 71st power, I need to use a 71st root. So what I'm going to do is 71st root the left side and 71st root the right side. And this root will cancel out the exponent so that you are just left with 1 minus r. Okay? And then to take the 71st root of something, first you have to type in the 71 and then press the math button. And if you look, that fifth option will allow you to take any number and put it in for x. So I'm going to choose the fifth option. And for some of you, it actually puts it in there. For others, you're going to see the 71 first, like normal size, because you just have an older operating system. And then what I'd like to do is have my calculator take all of this and put it in here without me typing it all in there. So one option is just type that all in there, but the other is if you look above the negative button, there's something that says A and S, and it will recall the most recent answer that you have, so this long decimal. So if I hit second and then the negative sign, which I'm going to do here, it's going to take this answer and just put it in there for me. So now I have this number. And again, I'm just going to write some of those numbers down, but I'm still going to let my calculator keep the whole thing. And so now to get r by itself, I'm just going to subtract 1. So this is still in my calculator, subtract 1. Right? So right now I have a negative 0.049 equals a negative r, but it's technically a negative 1r. And now I'll just take this answer and divide by negative 1, and there's my r. And what I don't want you to do is round too much. We're going to go 3 decimal places. And so now when I give my answer, I want to give it as a percent, so I want to move it back 2 times to the right, or take this and multiply it by 100. And from there, you know, I'm good with 4.9% is the rate at which it's decreasing. So how would I do this on the graphing calculator? So I'll go to my y equals, and I'm going to put my new population here, and then the old population formula here. And then I want to think about what my window would be. So let's start with the y's actually here. So the y's are all about the population of the pandas. So the least it's going to be is 124, the most it's going to be is 4,500. So my y min 124, I like to have a buffer zone, so I'm just going to make it 0. And my max of 4,500, I'm going to make a buffer zone as well and just make it 5,500 or 5,000. That would be fine. Now, I actually know the answer for what the x was. I know that x is this amount, right, which we did turn into a percent. So for this one, you have to realize that your rate is definitely a decimal answer that you have to turn into a percent. So from 0, I mean, you can try 20. I'm going to assume that 10 will work. We're going to see. I probably should have tested this out, but here we go. So there is the 124 line. Oh, and there's the other one. So see how it went up? Yeah, we definitely don't need 20. So I'm going to go back. Whoops, it's still graphing. We're going to let it think here for a moment. Sorry about that. It might be, so I think it's frozen. I'm going to pause and get it unfrozen right now. All right, I'm just going to go from not from 0 to 10, but like 0 to 2. And on the test, you will not have to worry about the windows. They will be there for you. All right, 2. Yeah, that's still really close. I mean, I can see it here, but it's kind of hard for you to see, so I'm going to go back to my window. So I've changed my window to 0.5. All right, and I realize this is hard for you to see, but I can see where they're meeting, and hopefully you can, right there. And as long as I can see them meet, second trace, choose, well, it's still going. Hold on. So second trace, choose option 5. Oh, it's not liking this. So anyway, I might be pausing the video here again. Sorry, I don't know what's going on with the calculator. All right, I just had to be very patient with my calculator to let it slowly finish graphing. It wasn't frozen. So anyway, moving the cursor close to where it is, and I'm going to hit enter 3 times. And when we're done, oh, I guess I didn't hit it. I think it's guessing. And then you're going to see that same number, that 0.049. So I had to be a little bit more patient with my calculator. All right, we got a few on the back. Let's take a look here. So you invested $4,500 into an account that earns annual interest of 4% that's compounded continuously. So that continuously tells me I'm using that third formula, and since that's flipped over, there is the third formula right there. How much money would you have in 5 years if you left the investment untouched? So they don't ask me to model the equation, so I'm just going to go straight into it. So y equals the beginning amount, that's the $4,500. E is a number. You need to use the E button, not 2.7. Your rate, that's 0.04, will be in the exponent spot now. And in 5 years, that will also join in my exponent. So going to the main screen on my calculator, the E button you should use is above this ln. You need to press second ln to get this E to pop up with the built-in exponent. So 4,500, I'm hitting second ln. The exponent will appear automatically, 0.04 times 5. Hit enter, and 5,496, and since this is money, I will go 31 cents. And think about, does your answer make sense? All right, so 4,500 growing at 4% over 5 years, you're going to see an increase, but it won't be that crazy of an increase. All right, your friend also invested $4,500 into an account that earns an annual interest of 4% that is compounded continuously. Unfortunately, for your friend, the investment decreased in value instead of increased in value. So how much money would your friend in 5 years if it should say he or she left the investment untouched? So since this is decreasing, this is going back to that. If it's going down, you need to make your rate negative. So the formula is going to look exactly the same. But now, because it's decreasing, I need to take this 0.04 and throw a negative in front of it. So I'm just going to type that into my calculator. So there you go, very similar. And now my answer should be lower. So unfortunately, your friend now only has $3,684.29 if I'm rounding. Finally, in July, you opened a Best Buy credit card that charged 0% interest if the balance was paid off in full in 3 months. At the time, your purchase was $1,600. 7 months have gone by, and you have yet to make a payment on your credit card. Best Buy is now charging you their standard APR, annual percentage rate, of 24%. But since they bill you, they're going to be billing you monthly. So how much do you currently owe? So here we go. So it's compounded monthly. That tells me I should be using the second formula. So this one. So to figure out how much I currently owe, I bought something for $1,600 and I haven't paid anything. And then it's going to be 1 plus their rate, so 24% as a decimal is 0.24. Compounded monthly means my N is 12. I will wrap that in another set of parentheses. And then here goes my exponent. 12 is appearing again. And this is in 3 months at the purchase. 7 months have gone by. So let's see. Hold on one second. All right. So the way this problem is set up, I'm going to pause for a moment. This doesn't quite match the formula. So to make it more match, we're not going to have to change anything here. But instead of months, this should be years. Okay, years instead, because the formula is based on an annual percentage rate. So just a heads up, I got to change years to months. It probably doesn't even matter in your head, but anyway, I'm going to finish typing this in here. So 7 years have gone by, and now I'm going to type this into my calculator. So give me one moment to do that. And, whoops, 4 divided by 12. Parentheses, and now 12 times 7. So this is what it looks like. So there's my annual percentage rate divided by the compounded monthly. There's the monthly again for 7 years. And now you owe, for the $1,600 item that you paid, you owe $8,443.73. Last one, if you continue to not make a payment, how long will it take for your balance to triple? So 1,600 tripling is now 4,800, so that's going to be our Y value, our new amount. And 1 plus, there's our fraction with those extra parentheses. And this time I want to know how long it will take to triple, so T will go back to T, and N is back in there. And we'll go back to our Y1 and our Y2. And we'll talk about that in just a moment. All right, so 4,800, and then I put the other side in. All right, make sure you get all those parentheses, all the zeros that you need to, and then the window. So I already know it's going to take, up here, it would take 7 years to reach this amount. So it's definitely not going to take 10 years for it to triple, because this is more than tripling. So as far as X min and max go, I'll have X min at 0, and X max, you know, I'll just keep it at 10. And then for my Y min, if this is about how much you owe, the least amount you're going to owe is 1,600. The most you're going to owe is 4,800. So if you want a buffer zone of 1,600, you know, you could drop it down to 0. And then if the most I'm going to owe is, I'm going for 4,800, I'll just keep that, like a nice buffer zone for 4,800. Now I'm going to hit graph. So there goes the 4,800 line. Here comes the other side. Oh, you definitely can't see that. Here you go. And as long as they meet, gotta wait for that little spinny thing to stop spinning. This calculator is going a little slow than some of the other calculators I use. All right. Then I hit second trace, choose intersect. I'm pretty close to it, as you can see, and I'm just going to hit enter 3 times. And X is going to be 4.623. So 4.623 years. And again, that's just 4 years. If you want to see what the 0.623 is, you could take it times 12. Oops. And about 7.5 months. So 4 years and about 7.5 months. That's just me rounding. But again, you can just write it like that. That's totally fine. And that is your review.